Hi all, welcome back to software testing course. So in the last class we had seen about psychology of testing, what would be the psychology of developers and testers while testing, and then we had seen the testing choices. In that we had seen in-house and outsourcing, advantages and disadvantages of the both. So today we'll get started with who does the testing. Okay. So, as we have already discussed in the psychology of testing, the development team it always tries to prove that the software works correctly. So, to overcome this difficulty, so in many organizations, the development team it will be different from the testing team. That means you'll have two separate teams, separate or dedicated development team and dedicated test team. So this would ensure that the testing is done without any bias and maximum possible defects are found before the release of your software. So, because of the complexity of the testing, the test team should have efficient manpower. That means if you do or your organization, if it has separate test team, then it should make sure it has sufficient people. So again, we had seen in this earlier topics that I had given you an example wherein Microsoft the ratio of developers is to testers is 1 is to 1, whereas in NASA it is 1 is to 7. That is, for one developer you have 7 testers, right? So hence, depending on the complexity of the project and how critical is your application, the team size would be different. Okay, so the large organization they can afford to have dedicated test teams for each project, but that is not the case for your small organization. It is very difficult for them to have a dedicated test team. But even then, the project manager's responsibility is to make sure that the software is tested by some other people other than the developers. Okay, so how can this be achieved? So one possibility is to make another development team to test the software. That means, say, suppose you have you have two projects running. So, and you do not have a test team, separate test team, but you want to make sure that your product or the project, whatever you have developed, it has to be tested someone other than the developer. So one solution for that is, if you have project 1 and project 2, then make project 1's development team to test project 2 and project 2's development team to test project 1. Okay, so another thing is you can recruit test engineers on part-time basis or via a contract basis. Okay. Now the aim of the project manager is to ensure that the quality product is delivered to the client and not to point the finger at the person whose module did the malfunction or whose module has defects. He has to make sure, the project manager has to make sure the quality of the product is ensured to the clients. Okay. So in this, who does the testing? We will see who are the persons that are responsible for testing. Who can do the testing basically? So first one, your developers. They can act as testers. Next, independent testing team. That is a separate testing team. The third one is buddy testing. Okay. So first we'll talk about how developers would act as testers. So if developers they carry out the testing, there are some advantages. So the advantages are, the developers they'll be familiar with the user requirements from the beginning of the coding activity. So they are in a better position to generate the good test cases as they know each and every functionality. So they'll be in a better position, right? Then your developers will have they are familiar with the structure of the program, like both code as well as the structures of the modules and subsystems, so they can do a testing better. Whatever, if they find out difficulty in um, while testing, if they find out any errors and all, even the debugging process would be easier because they are the one who will debug and they'll fix the code, right? So these are the advantages of developers while testing. Then what type of testing will be carried out by your developers? So basically the developers will carry out unit testing and integration testing. Unit testing is also called as component testing. Okay. Unit or a component, it is a smallest piece of software that can be tested independently. So only the developer can do this type of testing. Why? Because he knows the details of that component and maybe he is the one who has developed that particular component or the unit. Okay. Next one is integration testing. So while carrying out integration of different modules, right? So unit, say suppose you had seen just now unit testing, right? Unit is the smallest piece of software. So collection of these smallest pieces make modules, and modules, whenever if you have multiple modules and you integrate them, that time you have to test those modules, right? So that is nothing but your integration testing. So here the interfaces details between the modules need to be studied in integration testing. So this involves the code level details, and it would be best done by the developers. Why? Because they are familiar with the code, and as because test engineers are not familiar with the code, they cannot handle this testing. Okay. Next one, independent test team. So if an independent testing team, if they do the testing, they can do the testing impartial way without any bias. So the software can be tested thoroughly and many, maximum number of defects can be found out. So this word impartial testing, it came into picture here. Why? Because so your development team and the testing team would be different, right? As because we have separate team testing your project and they do not judge who has written the code, right? Like in person, they'll not judge who has written the code. So that's the reason why, because they can do a thorough testing and they can find out maximum number of defects. So there are few issues that has to be tackled if a separate testing team they do the testing. So the first one would be like the test engineers may not be in the project from the starting of the project, and hence they might not be familiar with the user requirements. So the test engineer, they should have an excellent knowledge of the application domain, and also they have to study the work products such as SRS document, design document, etc. Right? So the developers basically they would be like one or two developers, they would be basically involved in from the initial stage, that is requirement analysis stage itself, but that might be not true for the testing team. Okay. The second issue which has to be tackled is if the test engineers have to do the code reviews also, then they must or they need to become familiar with the programming knowledge and the source code, right? You cannot take some test engineer or the tester who has no knowledge of programming to a code review and tell him to judge the or to review the code. The next issue could be the next issue that has to be tackled is the test engineers need to be constantly interact with the developers, so to come out with a good testing strategy. This is very important, right? The last one is the test engineers need to realize that the developers are emotionally attached to their work. It is not like only the developers. Even we as a human being, if we have done some work, we'll be emotionally attached to it, right? And what will happen if someone comes and tells you that this is wrong, you have made some mistakes in this one, whatever you have done the work. So it you would be hurt, right? The same way the developers they would be emotionally attached to their code, and the test engineers need to be very careful when they are pointing out software bugs. So you need to tell, the damn thing is not working, but you have to tell them politely, right? So that is a communication skill which the testers should possess. Okay. Now, what type of testing would be done by the testers or the test engineers? So there are two types of testing. One is system testing and the other one is acceptance testing. So what would happen in system testing? So the system testing, it involves the testing of the software against its specification. That means if you have your SRS document available, then the testers they'll study the SRS first, then they'll start the system testing. That means they'll have or they'll consider the SRS as the initial document, or the basic document, and whatever is present, whatever the functionalities are present in the SRS, the test engineers will check the same functionalities are there in the product or not. That is system testing. Next one is acceptance testing. So this testing is done by the client in association with your development organization. Okay, a client person is involved in this particular type of testing. So even before the software is offered for the customer to test, the testing team, they should carry out a testing, and they have to ensure that the software offered to the customer for testing is of high quality. Now that is acceptance testing. Okay, so the next is buddy testing. So when two people sit together and they do the testing, it is called as buddy testing. So buddy is nothing but friends, peers, colleagues, etc. Right? So if a developer and a tester, if they work together at unit level testing, and the test code is written while the actual code is being developed, then this leads to a better software. That means parallelly the developer is doing the actual coding and the tester is doing the test code, like your test cases, scripts, or actual snippets. Okay, so this can be easier, right? Just to listen, but this is difficult to implement. Why? Because the tester, they need to have the programming knowledge while doing this activity, and again you need to have high manpower. If this activity, like the developer and tester, if they have to work together from the unit level, then the testers, uh, number of testers needed would be more. That means manpower requirement would be higher. Now this buddy testing is a concept, it is similar to your extreme programming concept, XP. So wherein the engineers work in pairs to do the development, right? Hope you know extreme programming from software engineering, wherein pair testing will be done. Like two developers will sit together, they do the code, right? One will be developing the code, the same time the other will be reviewing the code. So it is somewhat similar to that. Okay. Next, let's talk about testing phases. Okay. So if you start testing only after the software is being developed completely, okay, after entirely developing the software, you do the testing. That testing we call it as reactive testing. Okay. So on the other hand, if you start designing the test in the early phases of development, that means wherein your code is still being built, but before that only you start writing the test cases. Now that we call it as preventive testing, right? So there are two ways. One is reactive testing and the one is preventive testing. So reactive testing means once your product or the software is completely built, you do a testing, right? That is reactive. Preventive is like before the coding only you start some activity regarding the testing, that is preventive. So this testing needs to be done on every work product that is produced during the development. The work products like your SRS document, design document, these need to be tested through reviews and inspections, right? So again, these reviews and inspections we have seen in the software engineering. We will again talk about this in the future chapters. Okay. So testing of the software is done through the dynamic testing by executing the code. So during the course of your implementation or building the code, the testing is done at different levels such as your unit level, module level, subsystem level, and system level. Now in this testing phase, we'll see two types. One is V model and the one is testing and lifecycle models. The first one is V model. Now this is the diagram for V model. Okay. So to bring out the quality product, we need to test the output of every phase of the software development. Right? We had just seen this one. So this is a fundamental to produce the quality software. Now this is reflected in your V model, right? So this V model, it shows various development phases and its corresponding test phases. So in the software development process, the end user or the business operationals. So these needs are converted into user requirements. Okay, so the client, whatever their needs are there, they would be converted into user requirements. And from this user requirements, the SRS would be prepared. Your software requirement specification document would be prepared. And once that is there, you can proceed with the designing, right? Architecture and designing of your software. So based on this design, you then start coding, right? The first one would be component from unit, right? You do the coding. And now these are shown at the left hand side of your V model. Okay. So now let's talk about the right hand side of the V model. Okay. So first we had seen till component coding, or the coding, right? So the first one, each component or the unit has to be tested. Okay. Corresponding to your coding, the first testing would be like unit testing. The components are then integrated into modules, and these modules need to be tested. So this module testing or integration testing, this is um, done to check whether the design is correct or not. Okay, so unit testing is done to check the component or the code is correct or not. Integration testing is done to check the design is correct or not. So once all the modules are integrated, then you have the system ready. So then you can do the system testing, right? So system testing is done in accordance with your SRS. You take the SRS as the base and you test your entire project. Okay, so once the software is tested, okay, tested by the customer, so that we call it as acceptance testing. So acceptance testing is done to check whether the software meets the user requirements. Acceptance testing will be done by the client person. Okay, so once the testing has been done, acceptance testing has been done, the software will be installed in the operational environment or in the client environment. Now, this testing in the actual environment, it is also called as operational testing. And this testing is done to check whether the software meets all the business needs or the operational needs. Okay, so these are the various levels of your V model. So the right side, this right side, it describes the testing, and in the left side we have the user requirement through SRS, all the development phases here. Okay, this is about your V model. Next we'll see testing and lifecycle models. So in the last semester, we had seen different life cycle models, right? Such as your waterfall, prototyping, time boxing, etc. So, for your commercial projects, basically waterfall model will be used. Okay, and for the projects in which the user requirements are not very clear at that time, you will use the prototyping model. So, for the research projects, the evolutionary development model, iterative one, that would be used, and your spiral model is used for the projects involving innovation and strict deadlines. Okay, and the last one, synchronize and stabilize model is used where rigorous testing is needed. So in the waterfall model, basically the testing phase, it starts after the module integration is done, and hence testing is done in a on a reasonably mature model, right? So if you could remember the waterfall model diagram, so what happens in waterfall model? So when each and every phase gets completed, then only you can move to the next state or next phase, right? So once you have the coding, entire coding done, then only you can start testing the software. So here in the waterfall model, we use the SRS as reference for testing. Okay, so in the prototyping model, we first build the prototype. Okay, and then whatever the initial user requirements are there, so on that we build a prototype, and that prototype we show it to the customer and get the feedback, and this repeatedly occurs. In the evolutionary development model, the software is developed incrementally, and hence testing is also done incrementally. So This is incremental testing. Okay. So this involves a lot of testing effort because every time the system is incremented, that is you add some code to the existing code block, then what will happen? That testing has to be done again entirely. Okay. So even if you make small changes, you have to do the testing completely. So the projects that use the spiral model are high risk projects. So hence in every spiral and every round, so while studying the risk factors, the testability of the software has to be given lot of importance. And the projects that use the synchronize and stabilize model, they require very rigorous testing. So the testing team has to be in place from the beginning. So as periodic builds are involved, the testing has to be done thoroughly on each build and the feedback has to be given to the developers for further requirements. That's it for today. We'll conclude our session. Thank you.